Good morning, students. So today I shall again continue with chapter number 4, which is classes and objects, and the topic for discussion today shall be the inline member functions. Now just try to understand what is an inline function. Now look at point number 2. It says a function is defined as being inline if its implementation is substituted into the code where the function call was made. Now I shall explain this point with the help of the program logic, which is shown in the section 4.10 inline member functions in your book. Now this is the given program in your book. You just have to refer the book to try to understand this program. Now the very first thing that I am going to explain in this program is the concept of inline member functions. Now if you look at these functions cal_da, cal_hra and cal_gross inside this class known as employee, their implementation details are shown outside of this class known as employee. The implement details of these member functions are hidden inside this class. Instead, the class body ends here with the help of this semicolon, and the implementation details are defined outside the class with the help of this scope resolution operator. Now this is the function body of the member function cal_da, which describes the implementation details of this member function. Similarly, this function body describes the implementation details of this member function, which is cal_hra. And again, this function body describes the implementation details of this member function, which is cal_gross. So if we look from this perspective, we have tried to show some abstraction in the member functions cal_da, cal_hra and cal_gross inside this class called employee by hiding its implementation details. Because the function body of these functions cal_da, cal_hra and cal_gross are not present here, which describes the implementation part. Instead, the implementation details of each of these functions cal_da, cal_hra and cal_gross are defined outside of the class with the help of this scope resolution operator, as denoted by double colon. Another point to be noted in these member functions is that each of these member functions, that is cal_da, cal_hra and cal_gross, each of these are declared with the keyword inline. Okay, so each of these member functions cal_da, cal_hra and cal_gross are declared to be inline with the help of this keyword inline. Now the question is, what's the need of this inline keyword? Now let's say I am removing the inline keyword from the member function cal_da. Now in this case, come over here inside the main function. Now look at these two highlighted C++ statements. The first statement creates an object emp out of the class employee, and then in this statement, with the help of this same object emp, it is invoking or calling this member function cal_da with the help of this dot operator. Now this object emp can easily access this member function cal_da, which is present inside the class. This is because the member function cal_da has been declared as public inside the class. As you know that public members are accessible everywhere, that's why this member function cal_da is easily accessed by the object emp that has been declared inside the main function. Now note that this is the calling function, because the control is going to jump from here, and from here it is going to jump till here, that is the call function. But if you see here, the function body of this member function cal_da is not shown here. Instead, its function body is shown outside of the class. So again, from this portion of the program, the control is again going to move to this portion of the program. Here the function body for this member function cal_da has been defined with the help of this body region as represented by the opening parenthesis and the closing parenthesis, and this is the statement to be executed inside the function body. And all this can be done with the help of this scope resolution operator as shown with the help of this double colon. So for this member function, at first declare the return type double followed by the name of the class, which is employee. Okay, so double employee, and then put the scope resolution operator, which is double colon. So just write double employee double colon. Okay, so double employee and double colon, and after doing that, write the name of the member function, which is cal_da, and here it is cal_da. And once this is done, we can define the function body and show the implementation details like this. Now the important thing to be noted is that for this member function cal_da, the inline keyword is missing. That means I haven't declared this member function cal_da to be inline. In that case, what's going to happen now is that when the control will jump from this calling function into the call function, that is over here, and again till here, considerable amount of time is wasted, because jumping from the calling function into this call function incurs an extra overhead time, and that time needs to be minimized. We have to try to reduce that extra overhead time, because more jumping in the program from the calling function to the call function means more processing time is required to execute the program. Now we can minimize or reduce that processing time to execute the program by declaring this member function cal_da to be inline. Okay, at present this member function cal_da is not inline, so let me make it as inline. So here it is. Now this member function will be treated as inline because I have explicitly mentioned the keyword inline that is preceding this member function cal_da. Now just as I had put the keyword inline for this member function cal_da, then the control is not going to jump from this calling function into this call function, that is over here, and then till here. This is because an extra overhead time is incurred in the jumping process. So what can be done now is that instead of jumping from that calling function into the call function to execute the function body in the call function, this function body of the call function can be directly substituted over here, that is into this calling function. Okay, I hope this is clear. So instead of jumping the control from the calling function into this call function, what now it can be done is that for this call function Okay, since that was declared to be inline, its function body, that is this portion of the function which describes the implementation details of this function, can be directly substituted, or it can be directly placed into this calling function. Okay, so that the control need not jump into the call function, and that saves a considerable amount of time, because the jumping process involves a lot of time wastage. Now similarly, even for these member functions cal HRA and cal gross, they are also treated to be inline. So the implementation details of these two functions, which are cal underscore HRA and cal underscore gross, can also be substituted into the calling function, that is over here and here. The function body which describes the implementation details of the member function cal underscore HRA can be directly substituted into the calling function, that is over here, and the function body of the member function cal underscore gross. Okay, so this implementation part, or this function body of the member function cal underscore gross, can also be easily substituted or placed into this calling function emp.cal underscore gross, where empd is the object name to access the calling function cal underscore gross. And this entire substitution of the function body in the call function into the calling function is done by the compiler itself. So it is the compiler which does the substitution of the code present inside the function body of these member functions into the calling functions, which in turn saves a considerable amount of processing time. Now another thing to be noted is that explicitly using the keyword inline is not a guarantee that the member function will be treated as inline. By specifying the keyword inline, we are just giving a request to the compiler to treat this member function cal underscore DA as inline. However, the compiler can accept or even ignore the request. Now whether the compiler will accept or ignore the request, that will solely depend upon the number of lines inside its function body. Now if you look over here, for this inline member function cal underscore DA, it just consists of one C++ statement inside its function body. So the compiler is sure to accept this member function cal underscore DA to be inline. But there can be a situation sometimes this member function cal underscore DA, if it contains many lines of code, say for example if it contains 500 to 1000 lines of code, then it becomes very difficult for the compiler to treat this member function to be inline. In that case, if the function body is too long, the compiler may ignore the request of treating this member function to be inline. And when that happens, it is going to follow the traditional way of jumping from the calling function to the call function to execute the function. And with that, the idea of reducing the processing time of the program may not be fulfilled. So the best way to treat a member function to be inline is by reducing the number of lines of code inside its function body. If you minimize the lines of code inside its function body, then the compiler is sure to accept the member function as inline, and in that case the code inside the function body shall be directly substituted into the calling function, okay, which is present here inside this main function. So this part of the code shall be substituted directly into here, that is into this calling function with the help of the compiler. And this is how the inline function works, and it's nicely explained in point number 2 here. So just read: a function is defined as being inline if its implementation is substituted into the code where the function call was made. That means in the calling function. Okay, the implementation details, that is the code inside the function body, shall be directly substituted into the calling function, so that there is no extra overhead time to be incurred, as that was in the jumping process. Now read this point number 3. It says member functions inside a class are inline by default. That means whatever functions are declared inside a class, those functions are treated as member functions, and these member functions inside this class called employee shall be treated as inline by default. That means even if you do not specify the keyword inline for these member functions, they are still going to be treated as inline. Now if you see these member functions, input data, display, cal da, cal hra, cal gross, they are defined outside of this class. Okay, and the member functions cal underscore da, cal underscore hra, and cal underscore gross, they are explicitly mentioned as inline with the help of this keyword inline. But even if you do not specify this keyword inline explicitly, still these member functions cal da, hra, and cal gross will be treated as inline, because by default whatever member functions are present inside a class, okay, these member functions shall be treated as inline. So even if you do not explicitly specify this keyword inline for these member functions, okay, let me delete it to show it to you. Now these member functions are not treated as inline. Okay, but by default, since these member functions are declared inside the class employee, okay, that's why as per point number 3, they are required to be treated as inline by default. So for these 3 member functions, even if they are not specified with the keyword inline as in here, they are still declared to be treated as inline. So that's all about the inline function stuff. Now in the next video, I'm going to explain the logic of this program.